Hello, my name is Grover Borlotti, and I will be presenting on the role of experience in the gambler's fallacy by Greg Barron and Stephen Leiter. So the research question in this paper is, does the way we acquire information by sequential experience or by simultaneous description play a critical role in the emergence of the gambler's fallacy in a binary prediction task? The question addressed by Greg Barron and Stephen Leiter in their paper investigates how the method of acquiring information, specifically experiencing outcomes sequentially versus receiving a summary of outcomes all at once, affects the emergence of the gambler's fallacy in individuals. They aim to determine whether experiencing events over time leads to a stronger manifestation of the gambler's fallacy compared to observing the same events presented simultaneously. To explain the gambler fallacy, it is the belief that past events influence future events, even when they are independent and random. For example, if a roulette wheel lands on black multiple times in a row, someone might think red is more likely next, even though the probability of red or black remains the same for each spin. Why do people fall for it? Well, there's a few reasons. First off, humans are pattern seeking. Our brain is wired to recognize patterns even when none exist. Additionally, people might misunderstand probability and confuse independent and dependent events. And lastly, an emotional bias may be involved. Oftentimes, gamblers feel like they are owed a win after a losing streak. So, how do they measure the gambler's fallacy in this paper? Well, the key dependent variable is how often participants predicted reversals, choosing the opposite outcome or color after a streak. If participants believed that a streak of red meant black was more likely, they were experiencing the gambler's fallacy. The researchers measured how prediction patterns differed between those who learned through experience and those who learned via description. Additionally, there were a few other experimental manipulations that they observed. The first was the varied length of observed sequences. Some participants saw shorter versus longer histories of outcomes to test whether more exposure to randomness reduced fallacy. Also, they tested memory effects by controlling the number of past outcomes that participants could recall. The study examined whether short-term memory constraints influenced the fallacy. And lastly, they analyzed reaction times. Faster responses might indicate intuitive decision-making, whereas slower responses might reflect more deliberation. So the first experiment, titled 3 Presentations, Recency, and the Gambler's Fallacy, aimed to investigate how different ways of presenting past outcomes can influence the gambler's fallacy. And in this study, 108 universities, 59 male and 49 female, with the average age of 22, were paid $15 for participation and were subject to an additional performance-based pay, which could bring the total pay to around $20. The methodology behind this experiment were that participants performed a binary prediction task involving a virtual roulette wheel. The task consisted of 440 predictions where they had to guess the outcome of the next spin based on a visible history of previous outcomes. Outcomes were represented as colored balls, red and black or white and blue, and were randomly generated. So the 3 different conditions for this experiment were, first, the sequential condition. Participants predicted one outcome at a time for a sequence of 11 outcomes. After each prediction, the next outcome was revealed. A history window showed the last 10 outcomes. Next, in the simultaneous condition, participants were shown a sequence of 10 past outcomes all at once. They made a single prediction for the 11th outcome. The history was then cleared and a new sequence was presented. And lastly, in the third one was the auto-sequential condition. And this one's similar to the sequential condition, but instead of predicting the first 10 outcomes, participants watched them unfold automatically at a pace of 1 second per outcome. After seeing the sequence, they predicted the 11th outcome. For each condition, the process was repeated 40 times, resulting in 440 total predictions per participant. The sequences of outcomes were pre-generated and randomly assigned. So what did they find from this? The sequential and auto-sequential conditions showed significant evidence of the gambler's fallacy, which was a tendency to expect a reversal after a streak of the same outcome. The simultaneous condition, where all past outcomes were shown at once exhibited little to no evidence of the gambler's fallacy, and the study supports the hypothesis that step-by-step presentation, as in sequential and autosequential conditions, increase susceptibility to the gambler's fallacy by emphasizing the recency effects. So to conclude, step-by-step exposure to outcomes increases reliance on recent trends, leading to negative recency effects. Simultaneous presentation of past outcomes attenuates the bias, suggesting that the method of information presentation plays a crucial role in decision-making heuristics. And the findings align with the recency-driven cognitive mechanism proposed, where recent streaks draw more attention in sequential and auto-sequential settings, while simultaneous presentation encourages a more holistic view. So the other experiment that was in this paper replicated a similar experiment from 2004 from Burns and Corpus. However, it did not focus on recent outcomes as Burns and Corpus did in 2004. And the objective of this experiment was to examine whether the gambler's fallacy is influenced by the salience of recent outcomes. Specifically, it tested whether removing an emphasis on the last few results would reduce participants' tendencies to expect a reversal in a random sequence. So this was a smaller study with about 36 university students, 25 of which were male and 11 of whom were female, from a variety of different universities, and they were paid $10 to participate. The methodology is as follows. Participants were presented with 100 past outcomes from a simulated Las Vegas casino roulette wheel, with the red and black results listed in sequence. Unlike in Burns and Corpus, where recent results were explicitly emphasized, this experiment displayed all past outcomes in full, ensuring no specific focus on the last few spins. The final 4 spins were red, so RRRR, as it was listed in the experiment, but participants were not directly alerted to this streak. They were asked one question, which was, what will be the next outcome, red or black? And what did they find from this? They found that the gambler's fallacy was not observed, that around 50% of the students predicted black and 50% predicted red, showing no systemic bias. Compared to previous studies, this result supports the idea that recency bias plays a crucial role in the gambler's fallacy. When past outcomes were presented without highlighting recent results, participants were less likely to expect an imminent reversal. These findings suggest that the way historical data is presented influences how people perceive randomness, rather than an inherent belief in streak reversals. To conclude, this study reinforced the hypothesis that gambler's fallacy is driven by recency effects. When recent outcomes are made less salient, the fallacy diminishes. It highlights that presentation format, rather than just statistical reasoning, shapes people's beliefs about random sequences. So just to touch on Burns and Corpus, which the second experiment is replicating, it's a very similar experiment where participants were given a history of past outcomes and asked to predict the next outcome. However, they manipulated it so that some participants were explicitly told the last 4 spins were the same, while others saw a list of previous results without the emphasis of the last 4 spins. And what they find? They found that recent streaks were highlighted. Participants were more likely to predict a reversal, which showed the gambler's fallacy. And when past outcomes were presented without the emphasis on the last couple spins, the fallacy was significantly reduced. The study concluded that the gambler's fallacy is largely influenced by how information is presented. When people focus on recent streaks, they are more prone to expect change, even when the events are statistically independent. And this is relevant because in the second experiment, which replicates it, but removes the emphasis on the recent outcomes, it further tests whether recency effects drive the fallacy. So what did we find from the paper overall? The first thing was that the gambler's fallacy was stronger in experience-based groups. So those who observed outcomes in real time were more likely to predict a reversal after streaks, believing that randomness should balance out over short sequences. Secondly, description-based learners showed less bias when provided with statistical probabilities upfront. Participants were more likely to make rational, probability-consistent choices. Also, short-term memory played a role, as we saw through the recency effects. When participants were restricted in how much of the sequence they could recall, they relied even more on recent streaks, amplifying the gambler's fallacy. And lastly, people misinterpreted randomness as self-correcting. Many participants incorrectly assumed that randomness had a tendency to even out in the short run, even though true randomness does not follow such rules. Thank you for watching.